Well, cool. So we're talking about Rust today. Why don't you give us like a little introduction to Rust?
Yeah, so uh, let's see, what can I say about Rust? So Rust is a systems programming language. A lot of people compare it to C++. Plus plus. I've never written any C++, plus plus, but that's what I read, and as I'm learning, that's what I'm hearing. Um, it's used for it's like more of a low level language. It's got a really interesting kind of like memory like safety guarantee. It's got this ownership model, which is it's a little confusing and there's a little bit of a learning curve. But once you understand it, it's like okay, understanding references and memory and how Rust handles memory for you, like allocating, deallocating memory. It's really performant. It's type safe. So if you're coming from TypeScript or things like that, then you feel a little bit more at home. So
Gotcha.
yeah, I'm still learning Rust. I started maybe like a month ago, so a lot of it is still new to me. I've built
Yeah.
like one or two small programs.
Sweet. Yeah. Every time I hear about Rust, everybody seems to be like pitching it as like the performance about it. Like that's the go-to pro of Rust
Hmm.
is uh, the performance benefit you get from writing it.
Hmm. Yeah, it's super fast, and obviously when we're building this program today, like you'll see for yourself, it's like wow,
Super quick.
like you know less than a few seconds, or something that might take a little bit longer in say JavaScript or TypeScript,
Yeah.
depending on what you're building. So it's
Well,
pretty
cool.
cool.
Yeah, so jumping right into it. So today we're doing this programming a guessing game. It's just found right on the docs. I'm going to post in the chat, so if anyone wants to follow along with us as we do it, we're basically just going to go through step by step. Um, what is this game that we're building? So it's a guessing game. What's the outcome?
Yeah, so the outcome will be it's essentially a CLI app. So we'll run a command which will start the game.
Okay.
It'll s- um, it'll say, hey, like guess the number. And then basically it'll tell us, hey, your number's too low, your number's too high, or you got it right. And so it'll essentially loop until we get it right.
Okay.
And it'll be a number between 1 and 100. And we can change that obviously, but that's what we're hoping to achieve by the end of today's stream.
Okay. So we give it a number, and then because
Hmm.
it's randomly going to choose a number, we give it a number. We're going
Yep.
to try to guess what it is. It's going to say too high, too low. We continue to guess it till we figure it out.
Hmm.
Sweet. All right, let's do it.
Yeah.
Are you still in the live share?
Yeah. Got it right here.
Perfect.
Let's just test this out. If you can see Joe and hello.
Yep, we're live.
Cool.
We're good. Okay, so what is step one? Looking back at the docs here, setting up a new
Yeah.
project.
Hmm.
So I've seen this word cargo a couple times, and that's the
Yeah.
first thing we're doing here. Can you talk a little bit about what cargo is?
Yeah, so Cargo is the package manager. It's kind of like the build tool. It's kind of like the npm of Rust, essentially.
Okay.
So we're going to use it to initialize a new project here, and then we're also going to use it to build and compile and run our program.
Okay. All right. So the first thing we do. Oh, you already did it. You did cargo init guessing game. Oh,
Let's run it one more time.
okay. Yeah, do it one more time.
Okay. All right.
So this is similar to saying like npm init then, where it sets up like basically your directory for this game.
Yeah, exactly. Yeah, it's
Cool.
so there's cargo new and cargo init. Cargo init will run it in the current directory, and then cargo new would like create a new directory for you. Um, Kind of like if when you do like create React app, for example, it puts it in a new directory, things like that.
Okay. This one, the total file.
Yeah, so that would be analogous to a package.json.
Okay.
So you're gonna have the name of your program, the version. Um, you're gonna have like other things like the authors, the edition of Rust. So 2018 is like the like newest version, I guess, of Rust.
Okay.
And they're constantly adding new features, so it's not like it's 2 years old. And then we would add our dependencies, and there's other keys too, but these are the ones that come out of the box.
Gotcha. Cool. So we've got our source, we've got our main. So I assuming we could just run something, and we're gonna run this main function here.
Yeah. So every Rust program needs a main function
Okay.
to run.
That reminds me of
So
my one class in college of Java where I had to have a
yeah.
main function.
Oh, same kind of thing. Yeah. Right. Yeah. It's different because I'm like, coming from JavaScript or TypeScript, like you don't need to do that, right? You can call it
Right.
whatever you want. So
Right.
yeah. So yeah, if you want to in the terminal, if you want to run cargo run, and then we can kind of talk about the output.
Am I in the right
So
directory?
we need to, I think we need to CD into the guessing game. Yeah.
Gotcha.
And then run.
Oops, not that one.
Cool. Cool. So the cool thing about cargo run is if you haven't compiled yet, it will compile first and then it will run.
Nice.
So as we see, hello world is printed.
Nice. Okay. Cool. So cargo run, cargo init. So cargo's like the npm, like you were saying. That's how we run our commands. That's how we start our project. Got it.
Exactly.
Okay.
Yeah.
So that's the first step. We created the new guessing game.
Mm-hmm.
Talked about the cargo.toml file. So this is similar to like the package.json then?
Yeah.
Okay. Everything, you can notice that I come from a JavaScript background when I am slowly converting everything into JavaScript terms.
Right. Yeah. Same.
Okay, so yeah, so we did this first part. We did cargo.run. All right, processing a guess. Sweet.
Yeah.
Step one.
Yeah.
I'm
So
seeing lots
let's
of
do that.
interesting syntax here, like use, double colon.
Yep.
All right.
So
Why
yeah,
don't you
if
lead
you
us
want
out on
to,
that one?
okay, you got it. So the first thing that we're going to do, I'm just going to pull these up side by side.
Yeah, I'm gonna do the
Okay.
same actually.
Cool. Yeah. So let's just kind of write it out. And then we'll go line by line. So this use, I like to think of it as, it's similar to like a require in CommonJS or like with ES modules, like import a package. So do you have the RLS, the REST language server extension?
Let me check.
I think you should, but
RLS. Yes.
okay. So just out of curiosity, can you hover over std in the main.rs file?
Over STD. There you go. Yes. You get some interesting. Tells me about it.
Yes. So I think that's probably one of my favorite parts of Rust is like, um, at least like coming from other like I said, JavaScript or TypeScript, like you just kind of get this out of the box. So like you hover over and you get this awesome kind of like markdown explanation, like the Rust standard library. So std is the Rust standard library,
Okay.
which comes essentially with like built in with Rust. Um, it just kind of walks you through, gives you like lengthy explanations, links, examples. It's awesome. So like I point that out because if you're new to Rust and you're trying to pick it up on your own without like a tutorial or a course or like, the official documentation is pretty great.
Yeah. Good documentation is always a win, for sure.
Yeah. Yeah. So, okay. So, and then if you hover over the IO, so essentially we're importing this IO module, which contains things that are common for reading and writing and working with input and output. So, like with the command line, essentially.
Okay.
So we're importing that. Next thing we're going to do
And a
is, so
couple
we'll
print
delete this
lines.
hello world. Yeah. So this print ln. So we'll say, guess the number. Delete that, and we'll end with a semicolon because it's the end of a line. And so so again, if you hover over, I wonder if it'll work for print ln. It might not, but essentially this is what's called a macro.
Okay.
It's kind of like in my brain, it's kind of like a global function, but it's really not, because it can take a variadic number of arguments.
Okay.
So essentially, like we could pass in guess the number, um, and just to kind of show this a little bit, so we could delete number and replace it with this placeholder, which is the curly brackets. And then
Okay.
if we put a comma and then pass in, um, if we had a variable called number, we could pass that in there. So you could do that with a bunch. So if we
And how
had
do you
number,
reference the curly? How do you reference that inside the curlies?
so it goes in order. So let's say,
Oh,
so let me
gotcha.
add another one and just say like, I don't know, say it was called fun. And then we wanted that printed there. So obviously, like if these were variable declarations, it just goes in order. So it'll see, okay, here's a placeholder, here's an argument, here's a placeholder, here's an argument.
Gotcha.
So yeah.
Nice.
So let me delete that.
So yeah, we've got guess the number.
And then we've got please input your guess. So same thing, we're going to end with a semicolon. Then we're going to do let moot guess equals string colon colon new.
Okay, talk us about what's going on with that. Let, moot, and guess.
Okay, so everything by default, like all like variable declarations and everything, is immutable, like by
Okay.
default, right?
Okay.
So us using this moot keyword essentially says, hey, this is mutable.
Okay.
So that's that. Second part we got right here. So string. So if you hover over that, you'll see some documentation. So the string type is the most common string type. Yada yada yada. Kind of gives you an example. Um, so this colon colon is essentially accessing a method that's defined on the string struct.
Okay.
Um,
So
struct, I guess, is kind of like,
instead of like dotting onto it, we use the colon, double colon.
yeah, because we're doing it on the struct itself. And so if you hover over string and you scroll down in the examples, you'll see they give an example, let hello equals string colon colon from. So
Okay.
you're creating a string from a literal string.
Okay.
And then if you scroll down, you see hello dot push. So we're using the dot notation there because we're accessing a method on the instance of a string. So I
Okay.
know that's like, at least it was a little confusing to me. So it might be a little bit confusing um, when
No,
you
I
use one
think
of the
I mean
over the
it kind of
other.
makes sense where you were
Okay.
constructing. I mean, it's similar. It's still similar to JavaScript, at least a little bit in my mind. Where if you want to make a new
Yeah.
string, you can use the string constructor but
Yeah.
that it turns into an object, which then you can mutate and mess with, which is seems like what we're doing right here.
Exactly. Exactly. Yeah. I
Cool.
think no. I think yeah. That makes sense when you explain it that way.
Cool.
Yeah. So
Okay, so we've
now
got
we're
our
gonna
string.
call.
This is our guess, and now
Yep.
let's see. We're gonna do something with reading from our terminal or our console here.
Exactly.
Okay.
Um, so I'm
So we've
just
got
gonna write some stuff.
another IO. What you said was access like accessing the console. Is that what you said?
Yeah. Essentially. So like IO is like input output. So um, essentially like we're creating a new like std in. So if you hover over it, kind of explains it for us
Okay.
when operating in a console. So right, so we're going to be operating from like a terminal. So we're going to use this, um, and we're calling the read line method. And so we're saying, hey, when we're operating on the console, read whatever is essentially entered into the console, and then take that and like pass the buffer to the thing that we pass in, which actually I have too many parentheses. And so that's when we pass in guess. And
Okay.
so this like
That's
this
and.
and symbol,
Yeah.
yeah. So that's a little bit more advanced. Essentially, It's the reference operator. So um, if we take out mute for a second and we just had like and guess, so we're referencing this guess. So we're referencing it, but we want to mutate it. So we want a mutable reference. So that's why we use the mute keyword right there. If you scroll down in the docs, it kind of explains it a little bit as well.
Just about the mute of variables and mutability.
Yeah, so the and indicates that this argument is a reference, which we just talked about, which gives you a way to let multiple parts of your code access one piece of data without needing to copy that data into memory multiple times. So this is kind of like, this gets more into the complex features of Rust and memory management and ownership and things like that, which is explained later in the book.
Okay.
So right now we don't need to know a ton. References in general are immutable by default. So that's why we add that mute keyword there. So we're referencing guess because we want to use it here, and it's mutable. So essentially what we're going to do is read from the console and read essentially the input from the user into guess. Like we're going to store it in guess.
Okay. So reading it, muting guess, storing it into that guess variable.
Exactly.
Okay.
And so again, if you hover over read line, you can see the function signature, and you see the return type is IO : result.
Okay. I see that.
So result, if we scroll down a little bit to the examples, you kind of see this like this match statement essentially. So again, we're getting a little bit ahead. We're going to talk about match statements a little bit farther down in our program. But results it's essentially like an enum. And so it can either be an okay or an error. So okay meaning it was successful, and error meaning something wrong happened. And because of that, we're doing this like shorthand, like error handling, where we call .expect. And so if we get an error, then we're going to essentially print this to the console, failed to read line.
Okay.
So if we go back to,
yeah. So we did the expect. Okay. So now we're saying, are we automatically going to be failing them? Is that what's happening here?
No, we're not going to be failing them well, they should give us input and it should just work.
Oh, it just tells it. Okay. It just
yeah. So
the expect, is that like a catch?
kind of, yeah, exactly. That's
Okay.
a good way to think of it. Yeah. And then last, we'll just add this print ln. We can say you guessed. And again, that's kind of where we see those like crab pinchers, I think is what I heard them referenced once as the placeholder. And then the second argument, what we replace with it. So
gotcha. So can we run this and see what we got?
Let's do it.
Guess the number. Please input your guess. So I say 3. You guess 3. Great. Did I need to push enter? Cool. I assume I needed to. Yeah. Okay.
Yeah.
Sweet. It's pretty simple. So we've got a main function, couple basically console logs, or like printing to your console, your terminal. We've got one variable, and we're reading from the terminal with IO, from the console with IO, and then we're printing guess. So this is like our template string, passing it in our guess after it's been mutated.
Exactly.
Sweet. Okay, it's not bad.
Yeah.
It's easy enough.
Right? Yeah. So we got a first milestone, processing a guess.
Yeah. All right. So storing values with variables. Next, we'll create a place to store the user input. Okay. So I already did this.
Mm-hmm.
Okay. So yeah, I did talk about the difference between adding this mute and not adding it. So one's mutable, one's immutable.
Mm-hmm.
Okay. Handling potential failure. All right. So yeah, we talked about that. The expect is how we handle any errors we might get.
Exactly. And
then we print it to the line. All right, are we doing okay? So generating a secret number. That's is that the next step here?
Yes. So, yeah. So, do you want to?
Yeah, I
Well,
can do this part. What
okay.
are we just doing this? Let's see. Is
Yeah.
it
So,
just the
first thing,
R? Yeah, walk me through that.
okay. So, first thing you want to do is open the cargo toml file.
Okay, give me 1 second.
Okay. And I'll just follow you. Cool. Okay. And then, well, let me know when you're ready.
All right, I'm ready.
Cool. Okay. So, we'll go under dependencies. And on line 10, you want to add rand, RAND, equals, and then in quotes, 0.5.5. Cool.
Okay, easy enough.
Sweet. So yeah, so it's interesting because this is something that like kind of like a gotcha a little bit when I started writing some Rust. I was like, well, wait a second, like I'm going in and manually adding this in. Like, isn't there like a cargo add rand or something?
Yeah,
And right, because like of like like yarn add or like npm install, and
for sure.
I from what I've like read online, it's not a feature built into Cargo. There's like something, a crate or something that was created by the community that lets you do that,
Okay.
which I haven't tried, but I know there's discussion of potentially getting that feature in Cargo itself.
Yeah, yeah, that would be nice to just have a CLI tool or something you can use to just add packages without having to manually write them out.
Yeah, exactly.
Okay,
Cool.
so should we build
So
this? Is that the next
yeah,
step?
let's do it. Let's do it. So run cargo builds. So this will essentially like compile and build the project so that we could run it. So it's going to look at the cargo tunnel. It's going to be like, hey, you added a dependency. I don't have that. Let me pull that down from crates.io, which is the official registry for Rust packages, or Rust crates as they call them.
Okay.
Cool.
Does it create a? Do we need to
So
create a cargo.lock file, or do we
let's
already have
see.
that? It talks
It
about
should have
having.
created it for you.
Oh yeah, that's true. Okay, we do have that.
Cool.
Okay. Update a
So
crate to get a new version. Okay, so that's just cargo update. That I'm assuming. So that's kind of like npm, right? So you say update, and then
yeah,
it'll go through all your packages and update.
yeah.
Oh, should we be on 0.6?
Well, okay. I wonder. So if you go into the cargo toml, um, if RLS is working, like if the VS Code extension is working, it should show to the right the latest version. It's not working for me right now, but maybe it
Yeah, I
is for
don't
you.
see that. No, I don't see that.
Okay. All right. Well, we'll just stick with this version, I think, because I think the remainder of the tutorial goes through it with
Okay.
0.5.5.
Okay. All right. So now we're at generating a random number. Is that where you're at as well?
Yeah.
Okay. So back inside the main, we are okay. So this is where we're gonna do this let secret number thing.
Mm-hmm.
All right.
Yeah. You want to drive here?
Yeah, I can do that.
Cool.
So they've got it right here. Let secret. What was this? Secret
Secret
underscore
underscore
number.
number.
And so this, what is the R, the rand package doing? Like, what is
So
it
the
giving
rand
us here?
Yeah, so the rand package, I like to think of it like math.random. So like math.random, like, right, it's just a global, like it's just, you can just use it in JavaScript. You don't import anything. But here, we're importing this crate um, because it's outside, I guess, of the standard library. So
Okay.
it's kind of, I don't know, like the APIs kind of interesting. So again, if you hover over, so rand, it's like a random number generator, thread RNG, retrieve the lazily initialized thread local random number generator. seeded by the system. Sounds super complex and fancy. And then,
Yeah.
generate range, which is more like, okay, this, I get this. You start at 1 and it goes to 101, and it's inclusive in the beginning, like the initial number, and exclusive at the end. So it's going to be between 1 and 100.
Okay. And now I just on line 2, I just imported, or I'm using Grand. So now we're not doing
Mhm.
IO. What is RNG?
Yeah, so good question. So if you hover over, it'll say pub trait RNG core.
Okay.
So I actually have not gotten to this part in the book yet about
Hmm.
traits, so I can't explain it probably right now.
Okay.
It explains it a little bit, but I think traits they're kind of like they add functionality to things. So you're not
Okay.
like calling something, but because it's in the scope, we can use it. So my assumption is this trait RNG adds something to the rand like namespace so that we can call it.
Okay.
Um, that's my best guess.
Gotcha.
Yeah.
Sweet. Okay, so now we've got our secret number. I'm sure this is a squiggly. I'm getting a yellow squiggly. Is that telling me that I'm not using it anywhere?
Yeah, weird. It says unused imports, but we're using it right here. That's
Um,
strange.
I might have spelled it wrong. I purposely didn't copy and paste it just to make sure that so that I can, just to help me learn it a little bit better.
Yeah, actually, let's try something. So, in the terminal, can you run cargo check? So, cargo check essentially like compiles the project without generating output.
Okay.
And so it's a good way, it's like a faster way to like check, hey, am I doing everything? Like, is my code, does it
Okay.
compile? Is it type safe? Is the compiler happy?
Cool.
Uh,
That's nice.
yeah.
So
So I think
everything
we're good.
worked. Yeah.
Yeah.
All right. So we did
So
that.
if you want to add the line print ln and then the secret number is, and then we can just
Oh,
verify that it's working.
yes. Let's do that. And then here, secret number. So now we can do cargo run. Wait, is it
Yep.
run? Yeah.
Yep.
Okay.
Yep.
Secret number is 48. Cool. I'm curious. So
Cool.
why did we do 101? Is it like everything up until 101? So that way we include 100?
Exactly.
All right. Gotcha.
Yeah. And if you hover over uh, gen underscore range, so it says generate a random number or value in the range, inclusive of low, exclusive of high.
Got it. Makes sense.
Sweet.
Okay.
So we have our
Cool.
number, we have our guess. What's next?
All right. Next, comparing the guess to the secret. So we got our two numbers. Now we need to compare them. Looks like we're bringing in something else. Ooh, and this one's
Yep.
got a double colon too. Double colon. We got STD, CMP ordering. Why
Yeah.
don't you walk us through this part?
Okay. Okay. So same thing. We're going to throw this up at the top, use STD. So STD means it's from the standard library.
Okay.
CMP, I actually had to look this up because at first I was like, what, like, why is it called CMP? Um, so I believe that it's short for compare.
Okay.
And so, we're going to be comparing two numbers. So ordering is an enum. So enum essentially, there's different variants, and we're going to use that in our program. So if we go down to line 20, we're going to throw in what's called a match statement. So um, I think the closest thing in JavaScript is a switch statement,
Okay.
which is not like, I think some people will say that it's not true pattern matching because it's limited to like one value and you can't do as
Right.
much. This is a little bit more powerful. So we're going to call guess.cmp, and then we're going to pass in a reference to secret number.
Okay.
Um,
So why do we do? I think you said this. So why are we doing a reference here? Why can't I just like put secret number by itself?
So,
Because like up here on the print line, we just have secret number without the ampersand on line 10,
right,
but then we have to use it here.
right. So this has to do with ownership, and if we were to pass it, so from my understanding, if we were to pass it without the ampersand, like without the and sign,
Okay.
um, we would be passing ownership to this, like this part of the program. And so after the match statement was over, like down here, secret number would no longer be accessible.
Interesting.
For, I believe so. We might be able to actually like verify that, but um,
The error that I get is it's a type error.
okay, wait. Why don't you show that actually?
So like
What does
if
it
you have
say?
whenever I hover over secret number, it's telling me that it's a
Yeah.
type error. Like that's why it's the red squiggly.
Oh, that okay. That we will fix in a second. That has to do with
Oh, something different.
I think it's this. Yeah.
Got it.
So we can try it out actually and just kind of like learn from the errors. So let's do this right like that, and then so what we're going to do, like the match statement is similar to a switch statement. You've got these different branches. Um, so what we're saying is we want to compare guess to secret number.
Gotcha.
So we're going to call it ordering and then colon less. And so if the number that you're guessing is less than the secret number, we're going to say, hey, that's too small. And, as you can imagine, greater, same thing, but, it's too high or too big, I guess.
Gotcha.
And then if they get it right, we're going to say equal. So this is kind of cool. At least I thought it was kind of cool. Like,
Yeah.
the ordering is built into the standard library. It's pretty, I would say the API is pretty readable, even being new to Rust. So,
Yeah. The real Don says the match statement in Rust is absolute fire.
oh, yeah. Who said that? You said?
The real Don in the chat.
Oh, okay. Okay. I missed that. Yeah, it is. Right. It is. It's pretty, I've done a little bit of, like used it in a few programs and like, it's pretty awesome. It would be cool if like JavaScript or, TypeScript had something similar. I mean,
Yeah.
switch statement, you get close, but it's not the same.
Sure.
Okay. So yeah, let's actually, okay. So I think since we're like doing live share, I can't see the errors. So you said there's a type error.
Yeah. So we're getting a type error on secret number. It's saying mismatched types, expected string, and found an integer.
Cool. So yeah, so guess is of type string. Secret number is an integer. And so we
Right.
don't want to compare those because there's two different types, right?
Right.
And actually, like even if you weren't using like VS Code or like say the extension wasn't working, like can you run, or sorry, I'll do it. If we run
Yeah, go for
cargo
it.
check, so we get that same error message here.
Yep.
Right. So it points it out. So
Yeah. So yeah, how do we cast into the right type or use coercion here?
yes. Yeah, good question. So we're gonna go up to guess. Okay. And this gets interesting too. So after we get the number, so from 16 to 18, right? We've read the input from the user. We have
Right.
the number. So here is where we want to essentially like cast it, right? Or change the type.
Right.
So we're going to use variable shadowing.
Okay.
So let me write
Sounds
this out.
pretty high tech. Interesting.
right. So let me write this out and then we'll kind of walk through it. So, okay. So variable shadowing, right? So, like that is essentially like we're shadowing the name. So we're
Okay.
using the same name. So up here, it's an empty string. When we get to here, we change guess into essentially an integer.
Hmm.
So we'll kind of go through. So the colon and then the U32, this is a type annotation.
Okay.
U32, like numbers are a little bit confusing to me in Rust still because there's so many different types. It explains it a little bit in this doc. So like the default for integers is U32, which is an unsigned 32-bit integer. So unsigned meaning it doesn't matter, like there's no sign to it, like there's no positive or negative sign. So it's positive essentially.
Okay.
And in the docs they say it's a good default choice for a small positive number. And they talk about number types more in chapter 3 and go into a lot more depth.
Yeah.
So why do we need that? Like we'll see that in 1 second. So guess is a string. Trim trims the leading and trailing white space. The
Makes
reason we
sense.
have to do that is because when you are typing in your number to the command line and you hit enter, it adds a line break. And so we want to cut that.
Okay.
Parse
And then
is
parse,
a
pretty
general.
self-explanatory, puts it into a
Yeah,
number, right?
yeah, exactly. It's interesting though. The one thing that I learned when I was going through this again, parse is general. So it can, like if you hover over and read about it, it's so general it can
Oh,
cause
hold on
problems
one
with
second.
type.
I lost my audio.
Okay, you hear me? Dun da 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 dun da da da. Hey, all right, I'm gonna hop on the chat while you're.
I know that they can hear you still talking, so go ahead and keep going while I figure
Oh,
this
they
out.
can. Okay, okay. All right, cool. All right, let me just say hey to Don real quick.
And my headphones died.
I brought backup headphones just in case. Okay, so we're gonna keep going while Tyler is kind of getting his audio figured out. So, okay, so yeah, so parse, like I said, it's general. So this can cause problems with type inference. So the reason that we add the type annotation because of that, because it's so general, it doesn't know. I'm not sure what guess is going to be. I can't infer it. Can you explicitly annotate it? And so that's why we add that. The expect is the same thing, right? So parse, if you look at it, it returns a result. So again, it can be okay or error. And we want to handle the error case, so we can just do the shorthand and say dot expect. So I should be able to, let's see, kind of run this. So we'll run cargo check in just kind of a quick way. Hey, am I doing things right? Okay. Then we'll run cargo run. It's going to build. It's going to run. Please input your guess. So we see the secret number is 45. I'm intentionally going to guess lower. Too small, right? So our program ends right there because we have yet to implement a loop so that the user can guess multiple times. And that's going to be the next thing. And just so we can show that the error message is working, we're going to run it again. And notice how much faster it was because it's already been compiled. So it doesn't like unnecessarily compile twice. It's like, hey, I'm already, code's already compiled. Let's run. Secret number is 80. So we're going to type in a string. I'm going to type in hello. So here, the thread panics. We get the message, please type a number. Right? So not the most user-friendly, so we're going to fix that up later. But you get the point that the message from our expect call is shown to the user. So,
No, I'm still fighting audio issues. So keep going, right? Yeah, Joe.
okay. Okay, cool. So, well, Tyler's kind of doing that. We're just going to keep going. And if you have questions, feel free to stop me in the chat. I'm checking that every few minutes or so. Cool. So if we come back, okay, so we're just going to scroll down, and again, we're going through this tutorial. It explains it a little bit more in depth. We're just, the point of this is to kind of show you what it's like to build a small program. Cool. So the next section is exactly what we're talking about, allowing multiple guesses while looping, or with looping, rather. So here, you'll see in the example, if you have the docs up, loop is essentially this keyword, right, for a loop. So what we're going to do is throw this all in a loop. So I'm going to create a loop block. I'm going to select everything here and paste that in. Another thing I want to oh, cool, it formatted for us. Okay, I was gonna show you something. If you didn't have that set up for some reason, you can run cargo fmt, and it will format your code for you. But it looks like the editor already took care of that for us. Cool. So if we scroll down, so right now, if we were to run as it is, just with everything in this loop, we'll run cargo run. You can kind of see what happens. As you might be thinking, like, how do we stop? Right? If it would just go on forever until unless I typed in something wrong that made it panic. So we want to stop the loop, right? When the number is correct, things like that. So how do we tell the loop, hey, quit? So what we can do is quit when we get the correct guess. So what we're going to do is change this ordering : equal branch. So you'll notice, you don't have to use the curly brackets, but if you want to create a block, we do. So we need a block. So what we're going to do is print ln, and we're going to say un. And then we're going to use the break keyword. So the break keyword is used within a loop and says, hey, if you get here, break out of the loop. And that's what we want. So now let's run it again. We'll run cargo run. It'll compile. It'll run. The secret number is 32. Please input your guess. So let's test higher, bigger. Cool, 67. Too big. Still 32. Let's guess 32. Cool, we get UN, and I've used an @ sign instead of an exclamation point. So let's change that. Cool, so our break's working, our loop is working. Pretty good, right? Well, there's one thing that we are going to change, and that's handling invalid input. So essentially, we saw that kind of ugly panic message that happens when we enter something that's not a number or not an integer. So we're going to change that. And we're actually going to refactor our on line 21. We're going to use a match statement. So what we're going to do is match on guess, like the parse, right? So remember that parse returns a result. So a result can return an okay or an error. So it's perfectly suited for a match statement. So what we're going to do is delete that. We're going to, so match is the keyword and the thing you're matching on, and then the block. And then you have the different branches. So the first branch is going to be okay. And what you can do is okay returns a value. And so we can name that value. And so we're going to name it num. And then we're going to have an arrow, and we're just going to return num, right? And so what that does is if we get the guess, we trim it. We parse it into an integer. If it's successful, we get a number. We just return the number. And we do that because now guess is equal to that number, right? Because it's equal to whatever is returned from the branch on the match statement. Now, if it's an error, we don't really need that value. So we're going to use an underscore. And then we're going to say continue. And we do this. This is another keyword within the loop block. And so we say, hey, if we get an error, continue, so like restart the loop. So let's test this out. So I'm going to run cargo run. So we're going to compile, going to build, we're going to run. Okay. The secret number is 26. So
Okay,
let's see
I
what
can
happens.
hear you now, but I have a little bit of a lag, so keep going.
Okay. So right now we're just to get you back up to speed in case, because I guess you couldn't hear. We've added a little bit better error handling. So now if we type in something that's not a string, sorry, if it's not an integer, we should just continue the loop. So I'm going to type in
Okay.
hello. Cool. So it says the secret number is 26. So this actually isn't in the tutorial, but I added it in my own version. Let's refactor that error part of the match statement, and let's print ln and say, oops, that doesn't look like a number. Please try again. And then we're going to throw the continue afterwards. Make sure, semicolon. Cool. So does that make sense, Tyler? Okay.
Mm-hmm.
So now
Yeah.
let's do it one more time. So if we run cargo run, let's input a string, hello. So now we get our error message. Oops, that doesn't look like a number. Please try again. So looks a little bit better. So there's one last thing we need to do. We're printing the secret number, which we don't want. So we're going to delete that line. Cool. So Tyler, are you still there? So Rogue's got a question.
I'm pretty delayed, so just keep going without me. I'm listening though.
Okay. Okay, cool. Cool. So that's our program. So real quick, just going to head back to the chat. We got a question. So from Rogue, kind of an off-topic question. I was reading the docs and wasn't really sure of good examples and bad examples using box. Sometimes I get to Stack Overflow and it says to wrap it in a box, but how often do you heap allocate versus work around stack allocate? That one's going to be beyond me, unfortunately, Rogue. It's funny you bring up box because I was doing a little bit of Rust at work and box was being used, and that's new to me. Like I've only read the first 3 chapters or 3 or 4 of the Rust book, so I haven't gotten to box. So unfortunately, I can't answer that. Maybe someone else on the stream can, and if not, maybe we can follow up on Twitter and see if we can figure it out together. Cool. So thanks, Cami. So let's just do a quick run through of what we just built. Because we have a program. It's working. We're handling the errors. There's no warnings, no error messages from the compiler. So let's just kind of recap what we just built. So the use statement, right? We've got 3 here. We're using either external crates or we're using things from the built-in standard library. So remember, STD stands for standard, like the standard library. So rand, that's our crate for generating a random number. The second is CMP ordering. That's an enum that allows us to compare 2 integers. And then last, the IO module is essentially what allows us to read input from the command line and then work with it. Then we have just our program is just one big block, one function, essentially the main function, right? And so remember, your REST programs need a main function. That's what's called when you run it. So we print a message to the command line or the terminal. We say, hey, guess the number. And then in the background, we generate a secret number. And we use the rand crate, and we generate between the range of 1 and 101. And remember, it's inclusive at the beginning and exclusive at the end. So the possible options are 1 through 100. Then we have our loop block. And we loop because we want to allow the user to guess multiple times. So once we enter our loop block, the first thing we say is, hey, please input your guess. So we ask them for a number. In the background, we're creating an empty string, which is where we'll store their guess. Then we're using the IO module to read the line. So we read what they enter and essentially pass that buffer into our guess so that we can work with it. We have this expect because for some reason, if it fails, we want to handle that case, right? So we're handling the successful case and the unsuccessful case. Next thing we do is we're redeclaring guess. So we're shadowing the variable so that we don't have to have guess and then like guess integer when we parse it from a string to an integer. So this is nice. Like you don't have to think about, you don't have to have like unnecessary variables essentially. So then what we do is we match on guess. We call trim because when a user hits enter, it adds a line break. We don't want that. So we trim that, which trims the leading and trailing white space. Then we parse it. We parse as general. And so because of that, we have to annotate the type, saying, hey, this is an unsigned 32-bit integer. Essentially, it's a small positive number. And then we match because parse returns a result, which can be either okay, meaning it's successful, or error, meaning something went wrong, right? Like they put in something that's not a number. If it's okay, we get the number back. If it's an error, we print and say, oops, that doesn't look like a number, please try again. And then we continue the loop. So essentially, like we go back and go to the next iteration of the loop so that they can enter a new guess and try again.
Nice.
We print their guess so that they can, it's kind of like a verification, like, hey, or validation, like, hey, I typed in, 25. Is that what you got? And so we say, yes, you guessed 25. Then we've got our second match block. We're taking guess and we're calling compare, and we're comparing guess with our secret number. And because we parsed guess, this is an integer and secret number is an integer. We don't need to own it, so we're referencing it. And that's what the and symbol is. And then we have three possible cases. It can be less than, in which we tell them, hey, that's too small. It can be greater than, in which we say, hey, that's too big. Or if they guess it correctly, we can say, hey, it's equal, you win. We break from the loop and our program exits gracefully or successfully. Cool. So we have some
Cool.
new
Yeah.
people who have entered.
I'm still listening. Sounds all good.
Okay. Yeah, so that's basically it. Rogue, thanks for hanging out with us. Enjoy the rest of your day. So that's really it, Tyler. We've built this program, kind of like a good first stepping stones into
Yeah, I'll
Rust.
post this GitHub code.
Okay. How simple is it to add a GUI on top of a Rust game like this? Ooh, that's a great question. I don't know off the top of my head. I haven't built anything like that or really looked into it. So that's something that Tyler and I would have to check out. But I want to say it wouldn't be too hard. But again, that's without like hard evidence or something that we can point to. Cool, Tyler. Should we wrap up here, or what are you thinking?
Yeah, like I was saying, I'm gonna commit everything that we've done today. Put it on like a GitHub. I'll post a link here in the chat. And but yeah, thanks everyone for joining today. Hit up Joe for any other questions you might have. He's gonna be the go-to for REST. If you do have questions, definitely let me know. Hopefully I'll post this to YouTube, to Twitch. I think Joe's gonna post it on the Facebook open source YouTube channel as well. So you can catch this video there. Hopefully I can do a little blog post as well later on, putting together some of the notes that some of the stuff that we talked about today. But other than that, Joe, if there's any other questions you see in the chat you want to answer, I think we'll wrap it up.
Cool. Sounds good. Thanks so much for having me, Tyler. This was a lot of fun. Looking forward to, maybe doing some more Rust or some other streaming in the future.
Sounds good. Thanks. Talk to everyone later.
Cool. See y'all. Thanks for joining.